4.5 decades after launch and over 14 billion miles from Earth, the Voyager spacecraft still make discoveries. This record-breaking mission continues to pioneer human space exploration as the two crafts make their endless journey into deep space. While the craft may eventually be unable to contact Earth, they still send back valuable data, which has helped scientists understand the mysteries of deep space. Let's take a closer look at these legendary crafts and the terrifying discovery they have just made. The Voyager program is an American scientific program developed by NASA that launched in 1977. The mission consists of two robotic space probes, Voyager 1 and Voyager 2. The scope of the mission was to study the outer part of the solar system and gain knowledge about the outer planets and their moons. At first, the mission was quite simple. Voyager 1 had to study the planetary systems of Jupiter and Saturn, and Voyager 2 had to study Uranus and Neptune. Currently, the Voyager space probes are exploring the outer boundary of the heliosphere in interstellar space. As a result of their success, the mission has been extended 3 times as they continue to transmit useful scientific data. It was confirmed that on August 25, 2012, Voyager 1 had become the first man-made object to exit the solar system and enter interstellar space. A few years later, it was also confirmed that Voyager 2 also indicated it would enter interstellar space in 2018. The Voyager space probes are powered by radioisotope thermoelectric generators, a type of nuclear battery. This is a type of battery that is perfect for missions needing energy over a long period of time, which would be too long for fuel cells or batteries, and that can't rely on solar energy. It allows us to organize very long missions to happen. As such, it's predicted that the batteries will no longer be functional from 2032 on, about 55 years after the launch of the space probes, which is quite remarkable. However, as time passed by, various functions and systems of the probes had to be switched off to keep the main system in working order. Consequently, they'll be able to keep their current set of scientific instruments on until 2025. The space probes were initially conceived as part of the Mariner program, whose purpose was to launch various robotic interplanetary probes from 1962 to 1973 to investigate Mars, Venus, and Mercury. But as their mission has been changed to go study Jupiter and Saturn, they were removed from the Mariner program. At first, they kept their original name and were called the Mariner Jupiter-Saturn space probes. However, due to their evolution from the Mariner space probes, their name was quickly changed to Voyager. This new program took over many elements of the Grand Tour program. As indicated by its name, the Grand Tour program, developed by NASA, aimed to send 2 groups of robotic probes to all the planets part of the outer solar system: Jupiter, Saturn, Pluto, Uranus, and Neptune. Yet, this program was deemed too expensive, around $1 billion. Consequently, it was canceled and replaced with the Voyager program. For this reason, the Grand Tour program had a major influence on the Voyager program, as it fulfilled a lot of the planned objectives for the Grand Tour, except for a visit to Pluto. The Voyager program used the favorable alignment of Jupiter, Saturn, Uranus, and Neptune, which occurs only once every 175 years and was set to happen in the late 1970s. The space probes used gravitational assist, namely the use of the relative movements and gravity of a planet or other astronomical object to alter the path and speed of a spacecraft, and thus saving propellant and reducing expense. Through gravity assistance, it's possible to either accelerate a spacecraft, decrease its speed, or redirect its path. While Voyager 2 was launched first on August 20th, 1977, Voyager 1 was launched on September 5th, 1977 on a faster and shorter trajectory. Originally, the Voyager space probes were to conduct close-up studies of Jupiter and Saturn and their larger moons. As this mission was a real success and the probes were in good condition, scientists decided to go and explore Uranus and Neptune. The Voyager space probes made it possible to recover a lot of data and photographs of the most distant planets, thus allowing scientists to have precise details, which were until then still unknown, about the 4 giant planets and their moons. For instance, we were able to observe Jupiter's cloud forms and its wind and storm systems, as well as to discover the volcanic activity on its moon, Io. It was the first time that active volcanoes had been seen on another body in the solar system. It was also discovered that 7% of the upper atmosphere of Saturn is helium and the rest is hydrogen. Titan, Saturn's largest moon, was also studied in depth. Among its major discoveries was the discovery of a magnetic field around Uranus and 10 of its moons, but also the discovery of 3 rings and 6 unknown moons of Neptune. Furthermore, Voyager 1 and 2 sent us a lot of close-up photos of the giant planets. Among them is the pale blue dot taken in 1990 by Voyager 1. This famous photograph pictures planet Earth from a distance of about 6 billion kilometers. Planet Earth appears as a very small blue dot, lost in the vastness and greatness of space. As the main mission of the Voyager program was achieved in 1989, when Voyager 2 flew by Neptune, it was decided to extend their mission through the Voyager interstellar mission. The goal was to extend the exploration of the solar system beyond the outer planets, possible, beyond the limits of the solar system, beyond what we call the heliopause boundary. It can be defined as the limit where the solar wind from the sun is stopped by the interstellar medium. Reaching after the heliopause will allow the space probes to make measurements of the interstellar fields, particles, and waves that are unaffected by the solar wind, and thus providing scientists with invaluable data. As of today, the probes continue to send important data back to Earth. Currently, they mainly study ultraviolet sources among the stars, and they explore the boundary between the sun's influence and interstellar space. Voyager 1 has made a discovery that has left scientists baffled. The spacecraft has picked up the signature of interstellar space itself, a faint plasma hum, which experts have compared to gentle rain. Plasma has been part of Voyager 1's mission from its launch. The spacecraft discovered lightning strikes in Jupiter's atmosphere and studied how the solar wind tapered off in the outer solar system. And since 2012, scientists have turned the spacecraft's instruments upon a completely unexplored part of distant space. That's when Voyager 1 crossed the heliopause, where the solar wind, that constant stream of charged particles that flows off of the sun, is no longer strong enough to hold back the interstellar medium that surrounds our little neighborhood. Since 2012, as Voyager 1 has drifted ever farther from the sun, the spacecraft has measured the plasma around it. This part of the interstellar medium is mostly quiet. It's very faint and monotone because it is in the narrow frequency bandwidth. But every few years, the solar wind pushes back. Voyager 1 picks up those events as shock waves. For a time, scientists thought those shocks were the only way that Voyager 1 could measure the density of plasma out there. But now that scientists have heard this unexpected hum, they can track the interstellar medium between shocks, which can help them understand much more about a largely undiscovered expanse of space. Scientists believe there's much more low-level activity in the interstellar medium than they previously thought. This discovery means that now we know we don't need a fortuitous event related to the sun to measure interstellar plasma. Regardless of what the sun is doing, Voyager is sending back invaluable data about this plasma. It is detailing the density it is traveling through and records the changes in the space around it. It won't be easy to say goodbye to these trailblazing vehicles. Voyager 2 now has 5 remaining functioning instruments, and Voyager 1 has 4. All are powered by a device that converts heat from the radioactive decay of plutonium into electricity. But with the power output decreasing by about 4 watts per year, NASA has been forced into triage mode. Even after the Voyagers are completely muted, their journeys will continue. In another 16,700 years, Voyager 1 will pass our nearest neighboring star, Proxima Centauri, followed 3,600 years later by Voyager 2. Then they will continue to circle the galaxy for millions of years. They will still be out there, more or less intact, eons after our sun has collapsed and the heliosphere is no more, not to mention the Earth itself. If you liked this video, please also take a look at this one, which looks into NASA's new helical engine that breaks the laws of physics. Do you think NASA should launch a new Voyager mission?